Hello students. So this is question number 9 and 10 of paper 2 physics of JEE Advanced 2021. So the situation says that a pendulum bob of mass zero point 0.1 kg is attached with a massless string of length 1 meter suspended from a fixed point at a height of 0.9 meter above the frictionless horizontal floor. So situation is somewhat like this. There is a floor and this is like 0.9 meter, but the length of the string that we have used is more than 0.9 meter. It is 1 meter. So basically the string is slack right now and the particle, the bob is here. The mass of the bob is zero point 0.1 and then we gave it a horizontal impulse in this direction which is equals to 0.2 SI units, which means that zero point 0.2 divided by 0.1, so that's 2 meter per second. So we provided it with a speed of 2 meter per second. Now it will travel away from this point and then at some position the string will become taut, and whenever that happens this length will become equal to 1 meter, whereas this length is 0.9 meter. So if this angle is theta, then we are in a position to write the value of cos theta. So cos theta would be 0.9 divided by 1, so that's 0.9. Okay. Now what happens to the particle? Let's try to understand that by drawing a larger figure, and we want to calculate uh, the angular momentum of the pendulum just before the bob lifts off and the kinetic energy just after the lift off. Okay, so the situation is somewhat this, like this is the horizontal surface, the bob was here, the string was slack, then the bob traveled to this point, the string got tightened, and then this angle was theta. We already know the value of cos theta, it is 0.9. Now at this point the bob was traveling with a speed of 2 meter per second. Now what will happen? The moment string becomes taut, there will be an impulse in this direction. So in a direction perpendicular to the string, the momentum will remain conserved. So if this angle is theta, this angle will become 90 minus theta, this angle is 90 degree, so this angle will become theta. So the velocity component in this direction that we are going to get will be 2 cos theta. So it becomes 1.8 meter per second. So this will be the velocity component. Now we are in a position to answer both the questions. Before the string became taut, this particle was traveling with a speed of 2 meter per second. So the angular moment about this point of suspension can be calculated as 2 into 0.1, that is m into v into perpendicular distance, which is 0.9. Okay, so this becomes how much? This becomes 2 into 9, 18. So it becomes 0.18 SI units. Okay, and then after the string becomes taut, the speed of the particles becomes 1.8. That means the kinetic energy of the particle will be written as half into mass into v square, that is 1.8 into 1.8. So this becomes equals to what? This becomes equals to 0.162. I think you can calculate this. So this is what you're going to get, and since we have to mention the answer to 2 decimal points, so I will write 0.16. So going back, the value of J, all right, that's the angular momentum. So the value of J would be 0.18 and the value of uh, the value of K would be 0.16. So I hope you understood what was done here. It was a very simple question. I'm expecting that many students would have solved this question correctly. So thank you guys for watching the video. I'll present the solution to the next question in my next video. Take care. Bye bye.